Alright, here we start with Chapter 11. Chapter 11 is called Liquids and Intermolecular Forces. And to lead this off, we're going to look at some properties of the three main phases of matter: gases, solids, and liquids. We'll look at them in the order from the most diverse or the most spread out phase of matter to the most condensed phase of matter down here as a solid. So, first of all, some characteristics and properties for these states of matter. First of all, gases assume both the volume and the shape of its container. As we learned back in Chapter 10, whatever container holds it, that's its volume, and whatever the shape of that container is, that decides what the volume is. It expands to fill the container. It is compressible. As we learned last unit, you could take a piston and push it and squish the gas and also increase the pressure. It does flow. And it diffuses, meaning that it spreads out. So if you have the source of a gas, it will spread out from that source and go to somewhere else. And depending on its molecular mass, it'll move faster. If it's a lighter molar mass, it will move slower if it's a big, heavier molar mass substance. Liquids, these assume the shape of the container that it occupies. We'll say of the portion of the container that it occupies. So you could have a container shaped like this, and if it was only filled to here, well, it would take on this shape of the container right down here. It wouldn't take on the shape of this top part of the container. It does not expand, as we just illustrated here. It's only going to fill a portion of this container. It doesn't expand to fill the whole thing, whereas a gas would fill the whole thing. It would even escape from it if it didn't have a cover. It's virtually incompressible. Virtually, mostly, it flows readily. And so you can see that it has some good things in common with gases. And then diffusion occurs is slowly. So mix two liquids together, they will diffuse in and amongst each other, but it's not nearly as fast as like diffusion in gases. Solid, well, they retain their own shape and volume. And of course there are substances that kind of borderline go between these two, you know, like Play-Doh or like some liquid goop or slime or something like that, that, you know, is kind of between liquid and solid. But for the most part, you know, solids will retain their own shape and volume. They do not expand or contract to fill the container. They are virtually incompressible. So you have to be careful with this one, because of course somebody would say you could take styrofoam and you can definitely compress it, but remember, you're not compressing the solid portion, you're actually squishing the gas bubbles that are inside of that solid. It does not flow. And diffusion is super slow. Doesn't move very fast when you have a solid mixed with a solid. Not that it couldn't, it just doesn't go very fast. And so you can see on a particle view that, you know, gases are far apart and small. And as a matter of fact, in our gas laws unit, you know, we ignored that there were any attractive forces, and we ignored that the molecules actually took up any space because they're so spread out compared to the volume that they occupy. Liquids, on the other hand, are a lot closer together, and solids are even a little bit closer together in most cases. You'll even find sometimes where liquids are sometimes a little bit closer together than solids, like for instance in the form of liquid water. But for the most part, you can say that both the liquid and the solid are called the condensed phases of matter. So liquids and solids, these are the condensed phases, because those are ones that stick together a lot more. And then the gas one, of course, is the least condensed. They're far apart and very independent. So gases pretty much don't have any interparticle attraction, or at least we ignore them. So in terms of attractive forces, we would say that gases definitely have the least. And then liquids, they are a little bit more attracted. As a matter of fact, a lot more attracted than gases. And then we'd say that solids are probably a little bit more attractive, depending on what they are, but for the most part, solids stick together. And this change between solid and liquid and gas, or vice versa right here, is what this chapter is all about. It's all about what makes things change from this middle phase right here to a solid, or what makes it change from a liquid to a gas, or directly from a solid to a gas, or directly from a gas to a solid. These, of course, take energy to take place. And when we add energy to something, or we take energy away from something, then what we'll do is we'll cause those particles to move faster or slower. And this movement of particles causes the attractions between these particles to either become more or less. And of course, the gases have the least amount of attractions and therefore would have the most energy. Liquids usually in the middle, and then solids have the least amount of kinetic or moving energy, and therefore they would stick together the best. So in chapter 11, as we go along, we'll talk a lot about these attractive forces, and we'll look specifically at these interparticle attractions and the energy needed to separate them and change from one phase to another.